So just like we have an MA infinity process, we have an AR infinity process. So how do we express an MA infinity model? Which model did we use to convert it to an MA infinity? So any ARP model can be converted to an MA infinity model. If you recall, when we had
is this really any MA or any AR?
AR. So we had the characteristic polynomial on the AR side, and phi of the x-day would be equal to our noise, epsilon, say, standard noise assumption, means 0, variance thickness squared. I divide by phi of b on both sides. And I call that using a beta.
See?
What?
Just
The entire expression. The Greek letter. Sine of theta. Right. And that, is a linear process, or linear filter from last time. And that is true if the AR model is causal. The AR side, if it's right, then we would have causality. Under that condition, I used the fancy phrase for this, last time. For this condition.
Just one word. Tip. Is it something subtle?
Absolutely subtle. Or absolute something. We call it that way because you have an absolute sign and then some. In other words, the characteristic polynomial, of course, you've got to change the b to a letter z and then solve for it. So the characteristic polynomial must have roots outside the unit cell. Good. That's how we ended up getting an MA infinity model. We took any AR model, expressed it as an MA infinity. MA infinity, this part would simply reduce to a linear process. How do we get an AR infinity? Do you want to take a guess based on?
You take any MAP model and then turn that into an AR infinity.
That is correct. So any MAQ, we use Q or P. You can take any MAQ model and you can convert it to an AR infinity model. So what do we mean by that? Well, a typical MAQ model would have epsilon t plus, oh, sorry. Yeah, I can write it that way, but epsilon t plus theta 1, epsilon t minus 1 plus theta 2, epsilon t minus 2, up to theta cube epsilon t minus q. Right. And if I apply the backwards operator, what would happen to epsilon t minus 1 if I have to write it in terms of the lab operator? I use the letter B, didn't mean to confuse. B is the backward shift operator. Your textbook calls it as L. They are the same. I'm used to B, but the textbook uses L. So which one should we use today, B or L, since we started with B?
But backward shift operator is the same thing as the lag operator.
Might as well just continue,
B, right, it'll be easier.
because
to understand.
your tests are gonna be written by you, you're probably gonna use.
Probably.
No, he's just gonna put like a random letter. It's gonna be like W.
So theta 1, B times epsilon t, what happens to the second one? Backward shift. B squared epsilon t B raised q epsilon t. That's what we would end up having. So
Shouldn't there be a theta q times b to the cube?
I wrote it here, but forgot where. Now, that is a polynomial, do we agree? Polynomial in B. These are the coefficients, and that's some variable. If B is confusing, let's call it Z, Z squared, Z raised q. So that becomes a polynomial. So I can write that as uppercase theta equal to. Good.
What is that, between the white
What is that sheet?
This
It's like, it's like,
uppercase theta.
it looks like an M.
uppercase theta. So this is lowercase and that's my uppercase.
I'm just drawing a habit
Like, kind of looks like.
through the Legend of Zelda.
So do you see the connection between this and that?
Mhm. It's just shifted.
Same, but one is on the other side. We call it phi of B there, here, theta of B. Yes? And all the expression, excuse me, once I bring it to the denominator over here, I convert it to psi of B. And this is going to be a sum in terms of psi. And we have an infinite series in terms of psi values. And those psi values are the psi weights. Yes, that's from last time. What I'm going to do now is pick that equation. Just like I divided it in that case, I'm going to do the same thing over here. Divide by uppercase theta of B, xt equals epsilon z. Right? This is what we call duality. One over theta of B, I can call it uppercase pi of B. Right. So uppercase pi of B, xt, is epsilon t. Xt is equal to psi of, yes,
So uppercase pi is not the same as normal pi.
it's a capital letter. You know, just like we have lowercase c and uppercase c.
Okay.
Lowercase pi, uppercase pi. Oh, I mean, is that the number 3.1? No. So this is just a letter. But you can notice that pi 3.1415.
It's uppercase.
Uppercase, you could do this.
Makes sense, yeah, I get it.
It's just big.
I gained knowledge.
I think using pi as a regular is terrible.
Yeah, it is, right? But it's standard notation.
It's just the way it is.
So,
So using pi as a regular.
so over here, we wrote psi of B as a sum, and then we got an infinite series. When we evaluate phi of pi of B, you will also get an infinite series. When I do an example, this will make sense. Pi of K, B raised K. XD. And that is the same as saying if I apply B raised K to XD, backward shift by K units, it'll end up being K equals 0 to infinity, hyphen K, X T minus K. And that would equal epsilon z.
Can you repeat how that works again?
This,
Yeah, like where the B to the K went.
backward shift of data.
Oh, buddy, yeah, that,
So I apply the erasing, I shift time by k units. See the connection between the two. So here, if we have to write this, it will simply be sum k equals 0 to infinity, psi k, epsilon t minus k. Correct. When we write it as an AR infinity, we get that. MA infinity, we get this. So these are called the sine waves. We talked about that. Take a guess, what do we call these?
byways.
It's not pi. Question.
I was just trying to make like the Greek sound.
So pi weight. We need these, especially when we do AR models.
And the
AR,
sine wave is for the MA models, right?
yeah, this one, yeah. I'm just comparing that to that, and I've run out of space. So, ARP, we said, it's related to causality. MA cubed. It's no longer causal. What do we use instead?
Complex.
No. Starts with in.
In causal.
In and part of convertible.
Inverted.
Invertible.
You don't have it, it's a you come in.
I go, what does that start with N?
Right, it is invertible if, take a guess. Last time we said causal if the coefficients of the AR model P1, P2, P3, they were all less than absolute values less than infinity this time. What should it be here? It should simply be theta sub k.
This is supposed to be the AR.
Infinity.
Yeah, you have MA cubed, it should be AR.
So ARP is causal if its coefficients are absolutely summable. MA cubed is invertible if its coefficients are absolutely summable, right? If I extend this, what would change here? Uppercase phi would now change too. Look at the notes.
Uppercase pi.
Look at the notes.
Oh, it's your big theta.
It's a big theta. Right, last time we had uppercase phi of xt. So we wanted that characteristic polynomial to have roots outside the unit circle. Today, or in this case, we have uppercase theta of phi, and the roots of this must be outside the unit circle. Right? Same logic. There's equivalence. So if we have causality and invertibility, then the time series is stationary. Repeat that. Can you repeat that? If we have causality and invertibility, then we have a stationary series, guaranteed to be stationary. So if I just am looking at the MA model, all I need is for it to be invertible. And the series will be stationary. If I simply have an autoregressive model, all I need is causality, then it would be invertible. But if I have both, I would like for it to be both causal and invertible, for it to be stationary. Of course, there are non-stationary time series, but that's beyond the scope of this class, as I mentioned at the very beginning. Are we clear? Okay. MA1 model.
We AR maybe.
Yes, but good. So here is the model. XT is equal to epsilon t plus 0.39 epsilon t minus. Good. Do we agree that that is an MA1 model? No. What is uppercase theta of B? Well, that is theta 1. Theta naught is always 1. So if I apply the backwards operator, epsilon t plus 0.39 b times epsilon t, 1 plus 0.39 b epsilon t would be equal to xt.
I know the B is the same as the L. Are you using it now just to differentiate the two? Like we historically used the lag operator. Did you switch to the B just because we were doing something different?
No, I made a mistake when I started because I'm used to using B. So anytime I see uppercase B, it will naturally come to me as B. So I started the process and then I realized, oh, the book uses L. So all I did is swap the letters, L to B, that's it. Sorry about that. Didn't mean to confuse. So if you change that to L, nothing wrong. So that expression right over there would be my uppercase theta of B.
Am I dying? Yeah.
Now, if xt is equal to the uppercase theta of B, which we know what it is, divide by the uppercase theta of B on both sides. I will get uppercase pi of B. Good. So in short, uppercase pi of B is nothing but 1 divided by 1 plus 0.39 B. Correct? because uppercase theta of b is 1 plus 0.39b, so it's just 1 over 1 plus 0.39b full uppercase pi of b. Our objective now is to express that as a series. We've done this before with AR1.
But we still, for this, to finish off the equation, put the x
No, I'm just saying this part
is just
is that part is that.
done.
Right, I'm just stating that. As an equation, what I want to do now is take the uppercase pi of b and represent it as a sum. We have done this before, especially we use this to come up with that sum. Going back to maybe the first month or the second month of the month.
Oh, with analysis.
I think it's just taking a minute to connect in my brain.
Yeah, I mean, all we're doing is summing a bunch of things together.
Shift tracks.
So,
Just shift tracks, because we're still.
so if I have 1 over 1 minus k, that is simply the sum of sum I equals 0 to infinity a raised I, which would come to 1 plus a squared plus a cubed, blah, 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 blah. The requirement there is we need to have the absolute value of a to get it. Correct? So we have uppercase pi of b. So I need that infinite sum. This is the infinite sum of each geometric series. So since I have negative a in the denominator, I can do that. So what is the value of a now? Based on my side note over there.
It's still 0.39 because of the absolute value.
This is simply stating that the absolute value of a must be less than 1.
Oh, that's just negative point.
It's negative 0.39b. So in that sum, the sum can be written as negative 0.39b raised I or k. We like using k. So let's simply stick with what we did. K. Excellent. You see what I did there? I just replaced that entire infinite sum to that. I can split that up and write it as minus 0.39 raised k multiplied by b raised k x day equals epsilon t. What would happen if I apply b raised k to xt. And why this to that?
Right, because, oh no, I'm thinking of, yeah, absolutely.
Yes,
Would it be,
that was shift,
x t minus k?
x t minus k. And that would equal to x naught. So if I expand this, definitely this sum is an infinite series, right? Geometric series is an infinite series. If I expand this, I would have negative 0.39 raised 0, xt minus 0, plus negative 0.39 raised 1, xt minus 1, plus negative 0.39 raised 2, xt minus 2. I'll do one more term, negative 0.39 raised 3, xt minus 3, plus dot 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 equals, it's not. Negative 0.39 raised 0 is 1. That value is pi naught. Correct. Just like pi values, we have, just like psi values, we have pi values. Pi 1 is negative 0.39. Pi 2, negative 0.39 squared, 0.15. Right. 0.158.
With 152.
And pi 3 would be negative point, what do we get? 45 something.
0.06.
0, oh, 0.
Yeah, 059.
Well, negative 0.06.
Okay. And dot dot dot. Right. So those are all the pi weights. And I can come up with a general expression for pi k in this case. In this case, it is simply negative 0.39 raised k. K equals 0, 1, 2, dot, dot, dot. And just like how we always had psi naught to be equal to 0, excuse me, 1, pi naught would always be 1. They can always verify our answer that way. Good. So those are our pi weights. And if you look at this expression, that reduced to xt plus or minus 0.39 xt minus 1 plus 0.152 xt minus 2 plus or minus 0.06 xt minus 3 plus dot 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 equals x1c. What does the left-hand side look like? Does it look like an autoregressive model? Yes, no, maybe. we had just that is an AR1, right? Xt minus p or plus p, xt minus 1. That is an AR2 model, xt minus 0.39, xt minus 1 plus 0.153, xt minus 2. That is an AR3. Now we've got ourselves an AR infinity model. Does that make sense?
My favorite is AR0.
What?
No models.
It's just a thing. It's what it is.
Well, let's see if we can answer it since it brought this up. What is an AR0? What is an MA0?
Would it just be like the first thing, just XT?
XA? One. Okay. Let's just take this expression of it right? He said, order 0. Order 0 would mean none of the other terms should occur, right? You can only have xt. That'll go away, that'll go away, that'll go away, everything will go away. You would have xt equal to epsilon z. What does that tell you about xt?
It's just noise.
It's just noise. Same about MA0. If you have MA0, all you're talking about is noise. And is noise by itself useful to us? No. Noise plays a part in estimation, but noise in and of itself is useless. Good. So we've got this and we want to know if it is stationary. Well, just by the nature of the pi waves, we can see that they are decreasing. Correct. And not only that, it's alternating, so this series will converge. So when I add all the pi waves, their absolute values will definitely be less than infinity. That's one way to conclude that this series is stationary. Another way is to look at theta of b, uppercase theta of b. Can I erase the middle? Did we meet the condition for invertibility? Yes, because I was able to take theta of b from the right hand side, divide it out, and get an AR infinity series. Not only that, one plus 0.39b, if I wrote it as a polynomial, we use that lowercase theta of z. So 1 plus 0.39z. That would be the characteristic polynomial for the MA side. If we set that equal to 0, we'll have 1 plus 0.39z equals 0. 0.39z would be equal to minus 1. Z would be equal to negative 1 over 0.39, which is negative 2.656.
2.56.
Negative 2.56. Did the root of the characteristic polynomial lie outside the unit circle? Yes. That also means invertible. And since we are looking at only the MA side, because we started with an MA model, if it is invertible, then we have a stationary series. So the series is stationary as well. Good. So let's see if you can tell me what uppercase theta of B is equal to just by looking at it. 1 plus 0.74 B. Yes. Now, what is our characteristic polynomial? Simply theta of z is equal to 1 plus 0.7 z plus 0.19 z squared. As AR infinity. So AR infinity, to do that, we just have to take that part and divide, correct? So xt is pi b equals epsilon t, where pi of b is equal to 1 over uppercase theta of b, and that is 1 over 1 plus 0.7 of b plus 0.19 b squared. Yes, no, maybe. Good. We've done this before. How do you do it? Something very similar. We've done this before, perhaps a couple of weeks ago. So, with this long division, got to multiply by 1, so that I have 1 plus 0.74 b plus 0.19 b squared. Subtract, I will get negative 0.74 b, negative 0.19 b squared. Negative 0.74 b, we need your calculator. So negative 0.74 b. What is negative 0.74 times positive 0.74? 9 over 16. Point 548. Sounds about right. We'll just call it 0.55 b squared minus 0.19 times minus 0.74.
0.4.
Point 4 big cubed. Subtract. Those two would go away. And that would be 0.36 b squared plus 0.14 b. We'll do one more step on this. 0.76 b squared. We'll have, 0.36 b squared. We'll have 0.36 b squared. 0.36 times 0.74.
Which is 100%.
The next one would be 0.36 times 0.19. 0.7. That's 0.07 b raised. Subtract. Those two would go away. Minus 0.13 b cubed. Minus 0.07 b raised. Good. So I can keep on going, right? Worksheets can keep on going as we proceed painfully with some more division. But I don't want to do that. I look at what we have and I'm able to explain what pi 1, pi 2, and pi 0, pi 1, and pi 2 are. What is pi 0? 1, as always, right? Pi 1, negative 0.74. Pi 2, positive 0.36. We got lazy, so it's going to keep on going. And our expression for AR infinity is epsilon t is k equals 0 to infinity, I k, xt minus k. We know the values of pi k, so if I plug those in, pi 0 times xt minus 0 is just xt. Pi 1 multiplied by xt minus 1, negative 0.74 xt minus 1. Pi 2 multiplied by xt minus 2. And had we proceeded with this, we would get an AR infinity series. I'm looking at the pi weights and it seems like this series is going to be stationary. Now, do we have the roots of the characteristic polynomial? No, that's correct. So I looked at the values of the coefficients. They are alternating, and not only that, as I go along, the values of pi seem to decrease. So that sort of tells me that the pi's are going to be absolutely summable, which is why I said probably going to be stationary. Another condition is invertible. Is it invertible? Since this is an MA model that got transformed to an AR infinity model, all I need is the invertibility condition to be satisfied. If this is satisfied, then the series will be stationary. We already have i's converging by the looks of it, but I know they are going to. Two, I found the roots using R for the characteristic polynomial. The roots of theta z are minus 1.94 plus or minus I 1.21. Do they lie outside the unit zone? Yes. You don't need both of them, both the real part and the imaginary part to lie outside the unit zone. If one of them lies outside, the other is also going to be outside. In a sense, graphically, it'll be outside. So here, both of them are outside the unit circle. So clearly, we have invertibility. And since this is an MA2 model that got inverted to an AR infinity model, the series will be stationary. Does that make sense? So, stationary series. Because we can painstakingly do this for MA3, MA4, etc., but the process would be exactly the same.